Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syami bin Barudin, a final year student of BEKM, and in this video I am going to present about my project, which is optimization of vehicle suspension system using Firefly algorithm. So my supervisors for this project is Dr. Hairil Anwar bin Kastirin. So this project is basically about solving automotive engineering problem using artificial intelligence technology. Vehicle suspension system is one of the most important part in vehicles since it affects ride quality, ride handling, and safety as well. The main idea is to use Firefly algorithm, which is artificial intelligence technology, in optimizing vehicle suspension system for a better performance. So the problem is, first, vehicle suspension system does not absorbing shock efficiently, thus making the passengers to feel high impact of hitting uneven road surfaces. Secondly, vehicle suspension system is damping excessively when hitting uneven road surfaces. And lastly, suspension system unable to vary its stiffness according to the road condition. So the objectives of this project is, first, to design an intelligent controller based on PID control for a quarter car model semi-active suspension system using MATLAB Simulink. Second, to optimize vehicle suspension system using a proposed technique of Firefly algorithm for the purpose of improving its performance via simulation studies. And last, to analyze the performance of proposed intelligent control technique based on sprung mass displacement, which is body car damping, when a vehicle passes through a unit step shaped bump between Firefly algorithm tuning and manual tuning. So the scope for this project is limited to 2 degrees of freedom of the semi-active quarter car suspension system model, and this model only include road roughness and only vertical motion. And the controllable damper used in this project is MR damper of Baldwin model. And the intelligent controller used in these studies is PID controller. Then the evaluation is based on sprung mass displacement against unit step road profile. And last, this project is limited to simulation via MATLAB, and the result is presented in the form of time domain. So for literature review, I am not going in detail because in the previous presentation of FYP1, I already go in detail for literature review. So basically, literature review for this project has divided into 5 categories, which is, first, classification of suspension system, second, vehicle model design, third, controllable damper, fourth, suspension system control approach, and lastly, Firefly algorithm optimization approach. So for methodology, this is the flowchart where the methodology start with modeling quarter car suspension system, modeling and then modeling MR damper, and then designing Firefly algorithm with the application of motor controlling model, and then we check whether the Firefly can improve the system performance or not. If no, then we need to redesign the Firefly algorithm, and if yes, we go to the next step, which is modeling quarter car semi-active vehicle suspension system with PID control, which is the full system for this project. And then we check whether the system can be improved by adjusting the PID parameters or not. If no, then we need to remodel the quarter car semi-active system, which is the full system for this project. And if yes, then we go to the next step, which is apply and adjust the Firefly algorithm into the vehicle suspension system. And then we check the system performance can be improved by the Firefly algorithm or not. If no, then we need to readjust the Firefly algorithm, and if yes, then the methodology is complete. And this is the two equation that I use in this project, which is the first one, quarter car semi-active model equation, and second one, MR damper model equation. And from these two equations, I come out with this model. As you can see, at the left side is MR damper model, and at the right side is quarter car model. So this is the vehicle suspension system model, and this suspension system model is controlled by PID controller, where this PID controller will control the voltage input for the controller damper, which is the damper, which is the spring. And if the voltage is high, the stiffness of the spring will be high, and if the voltage is low, the suspension system stiffness will be low. and this transformation system will be depending on the road profile, and in this project the road profile is the unit step signal where the amplitude is 1. So this is the flowchart and the pseudocode for the Firefly algorithm. So the Firefly algorithm will start by initializing the Firefly parameters, and then initializing the population location, and then initializing the Firefly fitness. And then it will find the new best population, and then it will ranking the Firefly and find the best cost. And then the Firefly algorithm will check whether the iteration is maximum or not. If no, then it will repeat the steps from the find new best population, and if yes, then the Firefly algorithm is complete. So this is the result for this project. The Firefly algorithm tuning will be compared with manual tuning. And as you can see at the left side is manual tuning. The PID parameters is obtained through trial and error method. So I try to find the best PID parameters for the system, and you can see in the table at the left side that is the best PID parameters I find, and at the top is the output response, and at the right side is the Firefly algorithm tuning result, and the PID parameters is obtained automatically through the Firefly algorithm. And comparison between these two methods, the overshoot and undershoot of both tuning method is none, which is no overshoot and undershoot. And for the rise time, Firefly algorithm has faster rise time, where this is very good because it will stabilize the system much faster compared to the manual tuning. And for settling time, there is no settling time for both tuning method. And peak here means the gap between red signal and the blue signal. As you can see, for the manual tuning, there is an obvious gap between red and blue signal, while for Firefly algorithm tuning, there is unnoticed gap between those two signals. So the Firefly algorithm output response has better values of peak, which is smaller, which is 0.05, and for steady state error, Firefly algorithm has smaller steady state error, which is 0.002, while manual tuning has bigger steady state error, which is not very good compared to Firefly algorithm. So overall, Firefly algorithm tuning is better than manual tuning. So as a conclusion, all the objectives for this project are achieved, and the performance of PID control vehicle suspension system using Firefly algorithm has successfully met the expectation by having a better overshoot, rise time, settling time, and steady state error. And for future works and recommendation, I recommend to improve the vehicle suspension system model by changing quarter car model to half car or full car model for higher performance, efficiency, and accuracy. And second, I recommend to improve the MR damper model by adding voltage regulator into the model, because it will be more precise according to the condition of the suspension system. And the third one, I recommend to use the other controllers such as hybrid controller, because they provide better optimization since the adjustment is more precise. And lastly, I recommend to use the other Firefly algorithm approaches such as improved Firefly algorithm and advanced Firefly algorithm, so that the optimization of the system come out with better result. So that's all for my presentation for this project. Thank you.